Okay. So, in yesterday's class, what we have discussed? We have discussed about calculation of deflection in a beam, right? And we have seen that there are 4 different methods. What are the methods? Double integration method. Macaulay method is a specialized form of double integration method. Then second one, moment area or radial moment method. Then conjugate beam method, and the fourth one was Castigliano's method, right? Castigliano's method, where you will see that other methods are also there, but Castigliano's method and other methods of strain energy. So you will see on the strain energy how to find out deflection. Okay? So this Castigliano's theorem, moment area theorem, conjugate beam method, all will be coming as part of your next semester study. So when you will be studying structural analysis in 5th semester, at that semester you will be learning about all the other methods. In this semester, our focus in strength of material class will be particularly on double integration method. So in the previous class, we have learned about 2 things. One is how to find out deflection for a cantilever beam subjected to a point load, and also we have learned for a cantilever beam how to find out using a moment at the end of the beam. Today's class in the beginning we have learned, right? So now the question is, with the double integration method, can we find out the deflection of any kind of beam or any kind of simple supported or cantilever beam subjected to multiple loading conditions? Let's say multiple point loads are active on the beam, or the beam is subjected to point load and then UVL, then point load, something like that. That means, what I am trying to say, let's say I have a beam something like this, it's a simple supported beam. It is subjected to loads, let's say this. Okay? These are the loads it is being acted upon. Okay? So can we solve this kind of problem or deflection using double integration method? What is your take? What do you say? Is it possible or it is not possible? It is possible, right? However, it will become lengthy, right? So why it is possible? Why it is possible? The possible because I can take for each and every section. So you see, the moment equation, the problem of solving it using direct application of double integration method, how many sections you need to take, you see? So I have 3 loads. So one section will be here. So up to this, so if I start varying x from this direction, I will have to take one section over here. Next, I will have to take another section over here because the load is changing. So my x variation will change to here. So there is separate moment equation for that. Then I will have to take another one over here. Correct? And my x variation will be up to this. Correct? And then you see another one equation will come after this. So there will be another one x variation after this. So that means you see, for this 3-point load subjected to beams, when the beam is subjected to 3-point loads, you need to have multiple moment equations. Like this is the first moment equation, second moment equation, third moment equation, fourth moment equation. So all these equations will be giving rise to 2 constants each, because it is a double integration method. So for each of the cases for moment variation, you will be getting how many unknowns? 2 constants of unknowns, right? So you will be having 8 unknowns. And that is very difficult to find out, because from the boundary condition, whatever you have, from the boundary condition, it is difficult to get. Correct? So from the double integration method, Macaulay has given one method which is exactly similar to double integration method, and you can use that double integration method very effectively. Okay. So what does this double integration, what does this Macaulay's method say? Actually, what does it say? That you need to understand first. Okay. So what does Macaulay's method say? You see, instead of writing multiple equations, Macaulay has proposed that you write the deflection equation through a single equation. And how do you write it? That is the question. How do you write it? So for a single equation, you write it in a single equation. Let's say I have three loads over here, P1, P2 and P3. I have three loads in the P. It's a simple supported P. So subjected to P1, P2, P3, there will be reactions coming. So let's say my reactions over here is R1 and this is R2. There will be different reactions. If I take moment about the point at the end point and I find out the reactions, then I get two different reactions, R1, R2, R2. Let's say, R1 and R2 at the two surfaces. So you see, the first up to this position, if I write the moment equation up to this position. So first position, if I write, so what is happening? X is varying, right? X is varying, and you see at every step you are going forward. If I take X is along this direction, so every step I am stepping forward and crossing a load, my moment equation will be changed. However, with a beautiful concept that if X is becoming more than some value, that will become equal to 0. I will try to explain it using this equation concept, then it will be becoming clear. Okay. So what will be the moment equation? So just tell me what will be the moment equation. Minus Vi d2y dx2, correct? Minus Vi d2y dx2. This should be equal to, or I can say plus Vi d2y dx2, whatever it may be. So now if I take this one, so what is the moment for this from here to here? So if I take a section over here, what is the moment? So d2y dx2 is equal to mx, right? So if I write that mx, then what will be my moment? It will be equal to how much? R1 into x, right? So it will be R1 x. Is it clear? So what will happen to the next section when the P1 is being encountered? What will be the moment? Good? So if I from here to here, if I move, if my x changes from here to here, then what will be the moment? Good? What will be the moment? If I go from here to here, what will be the moment? Mx. First you tell me what will be the mx at this section if my x is over here. Why? R1, you have learned moment, bending moment theory. So you should be able to tell. If I want to tell you, if I want the bending moment diagram for this beam, then how do you do it? Each of the sections you take, and then you find out for each of the sections, okay, and do the variation, and then plot the bending moment diagram. So what will be the moment? R1 into. So x is now coming over here. So at this section, what is the moment? R1 into x. If I take this as positive, then this load is rotating it in this direction, so reverse direction. So this will be negative. So this will be minus P1 into, what should I write? So you see, this is the beauty. So from here to here, let us say the distance is A1. Okay? From here to here, let's say the distance is A2. Okay? कहाँ से कहाँ तक बोल रहे हैं? From where to where? From this support to this load, the distance is A1. From this support to this load, the distance is A2. From this support to this load, that means this load, the distance is A3. Got it? Is it clear? So now if this distance is A1, then you tell me what will be the moment Mx at this section? So R1 into X minus P1. So from here to here the distance is X. From here to here distance is A1. So what will be the moment? X minus A1. Is it clear? Have you understood? So can I now extend this equation? Can I now extend this moment equation over here? So if I write minus, so the moment equation becomes P1 into X minus A1. Correct? Is it clear? So now I tell you one thing. So suppose X is equal to A1. What happens? If X is equal to A1, what happens?
P1 0 eliminate.
X equal to A1. So that means X equal to A1. If I put, that means I am getting moment equation up to this point P1, just before this point P1. Correct? So that means for any value of X equal to the value of A1 or greater than A1. So if it becomes greater than A1, then what will happen? If it is becoming greater than A1, let's say it becomes A2, then what happens? The term inside that becomes negative. This one, right? So if this kind of thing happens, that means if this term inside the term X minus A1, X minus A2, these terms becomes negative or it becomes equal to 0, I should neglect. This is what is Macaulay theorem in the deflection calculation. And accordingly, I find out the value of the constants. So when I will be putting the boundary conditions inside it, then I should be finding out what the conditions, and when I put the values at that time, all other terms will be becoming equal to either negative or 0. So the negative terms and the 0 term should be negative. Have you understood? Is it clear to everyone? So that means, suppose now in this equation, let's say in this equation, if I now put x equal to 0, boundary condition. So at x equal to 0, what will be my y? At x equal to 0. So if I put x equal to 0 in this equation, you see, this will become equal to 0 and this will become 0 minus a1. So 0 minus a1 is a negative term or positive term? 0 minus a1, that inside that bracket, that term is positive or negative? It will be negative. So if the term becomes negative, I will neglect. And I will accordingly find out the constant of input. Is it clear? Have you understood? So this way, Macaulay proposed a generic equation for the double integration. And accordingly, depending on the value of the boundary condition, the terms whatever will be explained over here, if the terms becomes equal to inside the brackets, if the terms after putting the values becomes equal to 0 or negative, I should not consider that for the equation. I should neglect it. If it becomes 0, obviously it will neglect it. If it becomes negative, then also it should not be coming into picture for calculation of the boundary condition as well as for the integration constant. This is what is simple way Macaulay's theorem. Have you understood now? Or you are not clear yet? अगर clear नहीं है तो फिर से बताएं. Repeat. Up to this it is clear. Is it clear up to this? How to find out the generic equation. This is reaction 1, R1 into X. I am taking a section over here. So R1 into X multiplied by what? P1. This is my X. This is my A1, X minus A1. Next will be P2, X minus A2. Next will be P3, X minus A. This will be my generic equation for the moment. Is it clear? Now suppose I am putting X equal to 0. If I am putting X equal to 0, then what happens to these terms? After integration also, X minus A1 will become what? After integration, X minus A1 will become what? First integration के बाद क्या होगा बोलो? X minus A1 whole square by 2. So X minus A1 term will remain, isn't it? It is not that X minus A1 will become X plus A1. X minus A2 term will remain after integration. After double integration, what will happen? Will the term change? So after first integration, if I do the first integration, what this term will become? It will become X minus A1 whole square by 2. What this term will become? X minus A2 whole square by 2. After double integration, what it will become? It will become X minus A1 whole cube by 6. It will become X minus A1 whole cube by 6. Up to this it is clear. So if I am now considering dy dx term or y term, dy dx means these terms will come. So you see, although it is becoming whole square, whole cube, but the identity of that X minus A1, X minus A2, these are remaining. So now consider X equal to 0. Suppose I am considering, what is the boundary condition for simple supported beam? At X equal to 0, Y equal to 0. So if I consider that, then in that Y term, X equal to 0, Y equal to 0. So if I put X equal to 0 over here, this term will become negative. If I put X equal to 0 over X minus A2 whole cube by 2, what will become? X minus A. X is 0, so minus A3 or minus A2. X minus A3. X equal to 0. Minus A3. So all the terms will become negative. Correct? So once it is negative, you should not consider the square. Only the term considered inside the bracket you should consider. And if those terms becomes equal to negative, you consider them as 0. If it becomes 0, consider them as 0. If it becomes positive, then only you consider take into your consideration. Okay? And accordingly you calculate the constant of integration. Have you understood? If you do it in this way, then you see you will get two constant of integration. From this, what you are getting? You will be getting two constant of integration because you have written a generic equation for it. So you will get two constant of integration. One constant of integration you will get after dy dx. Another constant of integration you will get after y. So two constant of integration will come, and accordingly, if you can put the boundary conditions, the two conditions of two constants of integration can be evaluated. This is what is Macaulay's method. Have you understood Macaulay's method? And it is the generic form of the double integration method. And it is very, very effectively it can be used not only for point load, you can use it for UDL also. You can use it for a mixed UDL and point load also. Okay? So let us take one example. Then it will be more clear to you. So let's see through an example. So mathematical example gives you more clear idea. So let's take up one example. So let's say I have a simple supported beam. Something like this. So two reactions are coming, vertical reactions, and the total length of the beam, let's say total length of the beam is 20 meter. Okay, total length of the beam is 20 meter, and the two loads are placed at first load is placed, this is 4 kilonewton load. This is placed at a distance from here to here, it is 8 meter. Okay? And the second load is placed at a distance after this 8 meter, it is another 4 meter. Okay? And the second load is 10 kilometer. So now you are asked to find out what is the deflection at the underneath the 4 kilonewton load, underneath the 10 kilonewton load, and what is the maximum deflection in the beam. The beam is subjected to multiple loads now, right? So you will have to find out what are the deflections just below the 4 kilonewton load, what is the deflection below the 10 kilonewton load, what is the deflection of the beam which will be having the maximum. All the three things if you want to find out. And you are supposed to do it using double integration method. So if you apply the double integration method here, then you have to use the special case of double integration method, that is Macaulay's method. And what is the first step? First step is you have to find out what are the reactions R1 and R2. Correct? So find out please R1 and R2. Find out. So what will be R1 or RA and RB? So if I take RA, so if this beam is A and B, so what is RA and what is RB? So RA into 20 if I do minus 4 into how much is the distance left? 12 minus 10 into 20 minus 4 plus 8 12, so 8, right? This should be equal to 0. What I am doing? I am taking moments of all the forces about B is equal to 0. B is a roller support, let's say, at the end. So summation of all the moments about B should be equal to 0. Correct? So that way I can find out the reaction. So what will be the reaction? RA. Find out RA. What is the value of RA? Find out. 6.4. 6.4 it is coming. Calculator se karo 6.4 kilonewton. So what will be my RB? RB will be 4 plus 10 minus 6.4, right? Two downward reactions. So 4 plus 10. So that gives me 40 minus 6.4. So what will be my RB? RB will be equal to 7.6. So 7.6 kilonewton. Clear? So what I have done first step, reactions finding. Clear? So now I will put back the reactions inside the diagram, right? So here I should write now. Here I should write. So RA will be equal to 6.4 kilonewton and RB is how much? 7.6 kilonewton, right? Am I right? All of you have got it? How to find out the reaction? Have you understood? Now you try to write the double integral equation for deflection and apply the Macaulay's condition. So general equation you have to write, right? So general equation means my section X can be here, section X can be here, section X can be here. So anytime, any point the section X can be there. So what will be my generic equation? Generic equation will be EI d2I dx2 is equal to how much it will be? So RA into X first one. So if I take X over here, so RA into X, how much is this? 6.4 into X. If X moves from here to here, what will be my equation? 6.4 into X, 6.4X minus 4 into how much? So X now is being coming over here. So from here to here, the distance is X. So how much is X minus 8? Clear? Is it clear? Have you understood? Now next one will come where? The next section X will come over where? Next section X will be coming over here, right? After the load. So next section will come over here. So from here to here, this is X. So you see the equation. You see. So what is happening? RA into X. Then 4 X is this one. So 8 is subtracted. So equation remains same. 4 into X minus X. That is what is the generic equation of reflection. Okay. And then next minus 8. Sorry, 8 10. 10 into how much should I write? X minus. Please don't write X minus 4. Huh? That is a mistake generally is being done. So X minus 12. It is from the origin you have to take. All the distances should be taken from the origin. And where is the origin? Origin is here, the point P. Right? So from the origin, what is the distance over here? Up to the load, the distance is 8 plus 4, 12 meter, right? So it will be X minus. So this is actually the deflection equation. Have you understood? Now the thing is very simple. Only you have to put the condition. So next step, what I need to do? I need to do double integration, right? So first double integration you do. So first integration you do EI divided dx. This should be equal to how much? 6.4 x square by 2 minus how much will come? 4 by 2 x minus 8 whole square minus 10 by 2 x minus 12 whole square. Am I right? Or I have written something wrong? Pardon? Is it clear? और कुछ आएगा इसके साथ? Anything will come? C1. So let's write plus C1. So there will be a constant of integration coming, right? So this is the first integration. Now after that second integration. So what will be second integration?
EIY.
So second integration after CI, second integration will be EIY
6.4 x cubed by
equal to 6.4 x cubed by how much will come? 6 minus 2 to the 4, it will be cancelling out, right? Or you can say 4 by 6 it will come? 4 by 6? X minus 8 whole cube it will come. Correct? Is it clear? Next equation will come 10 minus 6 2 cube हो जाएगा, so 3 नीचे आ रहा है. 10 by 6 x minus 12 whole cube plus
C1x.
correct, absolutely correct, C1x plus these are the two equations you got. Have you understood? Is it clear? Okay. Now for simple supported beam, what is the condition? What is the boundary condition? I should not say condition. What are the boundary conditions? At x equal to 0, y equal to 0. This is the boundary condition. At x equal to 0, y equal to 0. This is the boundary condition. First boundary condition. So you put the boundary condition into this equation. So where should I put? And what is the second boundary condition? Because see, I am having what? I am having two boundary conditions. X equal to 0, y equal to 0. At x equal to L, y equal to 0. So what is x equal to L? X equal to, what is the length of beam? 20. Y should be equal to 0. These are the two equations I am having. So now you put back the values in the equation. Okay? So at x equal to 0, y equal to 0. First condition. Where you will put it? This equation. In this equation you put it. And tell me what is the value of C. If you can tell me, then you are clear on Macdonald's theorem. So x equal to 0 if I put, what happens? Y equal to 0. At x equal to 0, y equal to 0. So y becomes, this term becomes equal to what? 0. If I put x equal to 0, what this term will become? 0. This will become 0. If I put x equal to 0, what this x minus 8 term will become?
Minus 8.
0 minus 8. I am putting x equal to 0. So 0 minus 8. Is it positive or negative?
Negative.
It is negative. So negative means what? 0. Have you understood? Now it is clear. Opro, are you clear on this? So x if I put x equal to 0, then x minus 8. If I put this equal to 0, this will become minus 8, right? Minus 8 is negative term. So what does Macaulay says? If it is negative or 0, you consider it as 0, right? So I am considering it as 0. So this term will become equal to 0. Similar way, exactly same way, this will become equal to 0. And then I am putting x equal to 0, so this one will become equal to 0. So that means your C2 term will become equal to 0. Have you understood? So you have evaluated one constant of equation. So see the method's beauty, Macaulay's method. Okay? So double integration only we are using with some special implication and condition being applied to. Have you understood? We are very simple. It's not difficult at all. Okay? Now next condition, if I go. So next condition is little bit looks to be little bit difficult, but you see, you will have to evaluate. Because next condition, what does it say?
X is equal to N by 3.
So in the next condition, if I go, so I should write it over here, then it will be little bit clear. So please put the values for the next condition, then we will be able to understand. So what is the next condition? At x equal to 0, sorry, at x equal to 20, y is equal to 0. So that means value of x is what? Value of x is equal to how much? 20. So I will put for all the x's, I will put the value as 20. So now let's put it. So please, I am erasing this part. Huh? You know now why this much. So to have a space, I should write it over here. So you see, vi into 0, this will become equal to 0. So this left hand side will become equal to 0. What will be right hand side? So x is how much? 20. So put the value of 20. So 6.4, 20 cube by 6. Got it? Minus 4 by 6, 20 minus 8 cube. Right? So tell me now, 20 minus 8 is positive or negative? Positive. So it should be evaluated. You cannot consider it as previous जगह में क्या हुआ था? So minus 8 का cube नहीं किया था हमने. We haven't done minus 8 cube. We have taken minus 8 equivalent to as per Macaulay's condition. Right? So now here I have to evaluate because this term is positive. Now next term is 10 by 6. What is this term? 20 minus 12. Positive or negative by? Positive. So I have to evaluate, right? Plus. What are the two terms will come? Plus 27 plus 20 C1 and C2 I have evaluated already. C2 is 0. C2 I have got these earlier boundary conditions. So C2 equal to 0. Okay. So now in this equation, do you have any other term other than C1? No. So you can evaluate C1. Find out C1. So C1 का value निकालो. Got it? So have you understood the concept? You have understood. See, double integration only we are doing only with specialized condition being put from the Macaulay's condition. That's all. So find करो. हमारा इसमें कुछ minus 326.5 ऐसा है. So my calculation says it is C1 is equal to minus 326.5. This one, as per my calculation, it has come. Is it clear? So it is the numerical evaluation. That's all. So finally, you see, so what is the equation you are getting for deflection and flow? So final equation of deflection and flow, if I say, so final equation for flow will be this one. Final equation for flow will be Ey dy dx. This one minus this one minus this one, and what is the value of C1? Minus 326.5. And what will be the equation for deflection? Y So all these terms will be there. What is your C1? So minus 326.5 into 20. Why 20? X. We have divided the term x and C2 is equal to clear. So these two are your final equations, right? Okay. Now you tell me how to find out what will be the maximum deflection under the 4 kilonewton load. Let's say I ask you to find out what is the deflection, not maximum. What is the deflection under 4 kilonewton load? So what will you do? What is the deflection under 4 kilonewton load? What is the slope under 4 kilonewton load? What is the deflection under 10 kilonewton load? What is the slope under 10 kilonewton load? Can you find out? Yes, you can. So if I tell what is the deflection under 4 kilonewton load, that means what will be the value of x? X will be equal to 8. Where is the 4 kilonewton load? At 8 meter distance. So x equal to 8. So 4 kilonewton load, under the 4 kilonewton load, if you want to find out this deflection, then x equal to how much? 8. So if I put at x equal to 8, so now again the Macaulay will come into picture. That x equal to 8. Okay? देखने में लग रहा है बहुत बड़ा कैलकुलेशन हो जाएगा, but you see the calculation will become shorter. Okay? X equal to 8. So put at x equal to 8. What will be the thing? At x equal to 8, what will be EI into Y? Tell me. EI into Y will be equal to 6.48 cube by 6. Then minus. Then you have to tell me what will be minus. At x equal to 8 we are saying. So 8 minus 8. What is the value? 0. I did not know. कोई कैलकुलेशन नहीं. Got it? X equal to 8. Next term 8 minus 12. क्या आएगा वैल्यू? Minus 4. Should I calculate? 0. Have you understood? After that minus 326.5 into x. X पे कितना बैठेगा? 8. It will not become 0. Okay? So minus 326.5 into. This will be your deflection at a point where the load is like 4, when the 8 meter distance, the 4 kilonewton load is at 2066, something like that. Okay, so if you calculate, you will get EI into Y is equal to minus of something, right? Minus of 2066, something like this you will get. Okay, and how much will be the deflection then? Deflection will be Y is equal to minus of 2066 divided by EI. Okay, now if you know the modulus of elasticity of the material, if you know the sectional property I, then you divide it, you will get the exact equation. What? Have you understood? What will be the deflection under the 8 kilonewton load? What will be the deflection under 8 kilonewton load? So under the 8 kilonewton load, sorry, 10 kilonewton load, not 8 kilonewton, sorry. What will be the deflection under 10 kilonewton load? How do you find out? In place of Y, I will put what? In place of Y, I will put Y is equal to 10. So what will happen to this? 6.4, 10 cube by 6 minus 4 by 6, 10 minus 8. Will it be there or not? 10 minus 8 is positive term, so I have to give. After that it is coming? 8 minus 8 plus 4, 12. So 12 minus 8. 12 minus 8 is plus 4, so I have to consider this term. Here 12 minus 12, 0. I did not consider this term. Last term will be there again. Last term में x का multiplication कितना होगा? 326.5 multiplied by 12. That will give you deflection under 10 kilonewton. Have you understood? Is it clear? Okay. And if you know the value of E and I, you can find out the exact deflection. Okay. Now tell me, where will be the deflection? Where will be the deflection maximum? ये तो पॉइंट लोड के अंडर में डिफ्लेक्शन कैलकुलेट हो. Now if I ask you where the deflection will be maximum and how much will be the deflection? See, where the deflection will be maximum, if you can find out, then you can always find out how much is the deflection. So how do you find out where the deflection is maximum? Where the deflection is maximum? Tell me. Let's say find that. So, if you remember the normal deflection curves, okay, normal deflection curves, there is a relationship between deflection and slope. So, wherever there will be maximum deflection, the slope will become equal to 0. Because you see, this kind of thing will be deflecting something like this, right? Okay? So, wherever there is a maximum deflection, there will be a horizontal line parallel to this. That means the slope is equal to 0. Okay? At other point there will be some slope. So I can make this equation very effective through this one. Because what is slope? Slope is dy dx. Slope is what? Dy dx. So wherever dy dx becomes equal to 0, wherever dy dx becomes equal to 0, at that point deflection will be maximum. Have you understood? So if dy dx becomes equal to 0, my deflection will be maximum. Now from this problem, you can see that deflection will be obviously maximum between this 4 and 10 kN load. Because it cannot be beyond 10 kN load. 4 kN load chalu hua, then there is another one 10 kN load, so the deflection will be maximum between 4 and 10 kN. It doesn't matter if you consider the other part also. But again you got to apply Macaulay point. Okay? So if I consider that the deflection will be in between somewhere, then what will happen? In between somewhere means here, let's say. So that means x will be lying somewhere in between this 8 and 12 meter. So let's say x equal to 9 meter. Assume x equal to 9 meter. Okay, but I have to put x as variable because I am putting it in the deflection equation. I need to find out the value of x, exact value of x. So let's say if I put the exact value of x, then what will happen? So dy dx becomes equal to 0, right? I need to find out x. So what will happen? So it will become 0 is equal to 64 x square by 2 minus. I am having more than 8, right? Some point will be coming which is more than 8, right? Oh, sorry, 6.4 x square by 2 minus, what is the next term will come? This term will also exist. Why it will exist? Because the point of maximum deflection will come beyond this 4 kN load. And this 4 kN load is at 8 meter distance. So, if I put any value of x, which should be more than 8 meter, right? So, if x is more than 8 meter, then what is this term will come? This term will be positive. So, I have to consider this. So, term will come minus 4 by 2 x minus 8 whole square. Next, you tell me. Next, if I consider x over here, somewhere in between 10 and 12. So, what will be the value of x? It will be lesser than 12. So, it will become negative. So, I did not consider this. So, I should consider this as 0. And then this term will come minus 326. Along with this term will come 326. Have you got it? So, you are getting the equation of x. Now, you are getting an equation of x. So if you solve this, you will get a quadratic equation. Quadratic equation means in terms of x square you will get one equation. Okay? So once you solve this quadratic equation, this is the home task I am giving you. Okay? 2 days holidays are there. So next week I will check it. So So if you solve for x, then what do you get? If you solve for the x, then what do you get? You will get the distance at where the maximum deflection is happening. Okay? So this one will be a quadratic equation, and you can solve x equal to plus minus root over of b minus a. That Siddhartha formula you apply, and using Siddhartha formula you find out what is the value of x. So you will get a plus and minus value. Out of that you consider the plus one. Okay? And using that value you are getting, so whatever value you are getting, at that point your deflection is becoming maximum. Right? So what will be the maximum value of deflection? The maximum value of deflection, again you put back the value of x into this equation. And in this equation, wherever you put it, you see value will become less than 12. So this part will be obviously equal to 0. And it will be greater than 8. So here the value of x will come, put the value of x. Whatever you are getting from this one, put the value of x over here, and you find out the maximum deflection. So maximum deflection is your own task. Okay? Monday's class I will see. This one. Now Friday I am having a class? No. No, Friday I don't have. With the Monday's class I will see. So have you understood? So I think I have discussed everything about double integration method. So we can conclude it here, or we can take another one class on this where I think I should take another one class where I should explain also about the uniformly distributed load. One or two problems for uniformly distributed load, which I will just give you hint and you will have to solve it your own. Because I will give you one tutorial problem. A tutorial sheet is going to come for this. Okay? So please go through it, and then we will conclude in the next lecture about the deflection calculation using double integration method. Thank you.